Hi guys, welcome back to another video of Solidity Basics. In this video, we'll cover function modifiers. So function modifiers are code that can be run before or after function call. These are generally used to restrict access, validate input, and guard against some re-entrancy hacks. So you can think of modifier as a wrapper on top of function, and whenever you call a function that has a modifier added to it, the flow of execution first goes to the modifier, and you have this underscore which transfers the control of execution back to the function, and then when the function execution is finished, the flow of execution comes back to the modifier. So this is how a modifier is in a way wrapped around a function call, and we'll learn more about it while we walk through the contract. So in our contract here, we have first a constructor that sets the owner to the one who is deploying the contract, and then we have a modifier only owner, which basically states that the message sender should be owner, which means whoever is calling the function should be the owner of the contract. And whenever we add this modifier to a function, it would first do a check whether the person calling the function is the owner of the contract or not. If it's not, it would throw an error that it's not the owner. And if it is the owner of the contract, the flow of execution goes back to the function call. Next, we have another modifier which does address validation. It takes in an address and checks whether it is a zero address or not. It's a simple check, and it does the check and then transfers the flow of execution back to the function. So you'll notice that modifiers are used to add some basic security parameters around a function. You do some checks and then only you allow the function call to execute. So we have this function here, change owner, which has only owner and valid address added as function modifiers. So this function is supposed to change the owner of the smart contract, but before doing that, you need to make a check whether the owner of the smart contract is invoking this function and whether the new address is a valid address or not. When you do both of those checks and it passes, then only you allow the function to change the owner of the smart contract. In the next example, we have a modifier called no reentrancy. So reentrancy hacks are a very popular kind of hacks when it comes to Solidity smart contract. And a TLDR of them is that a function can call itself while executing its own logic. This is called recursion. And this is many times used in live smart contracts to hack and drain the value out of the smart contract. So reentrancy guards basically prevents the function to call itself while it's executing. So the logic is simple. We have a logged variable. If you have already worked with mutex locks or read or write locks, you would be familiar with this concept that we have a logged variable which is true when this function starts executing, and if the function calls itself again, this condition becomes false. So in short, this modifier won't allow the function to re-enter itself while its own execution, so it would prevent recursion in a way. Okay, let's check this out on remix id. So we have a smart contract here. We'll compile it and then we'll deploy it. So here we have to change the owner of the contract. Right now the owner of the contract is set to our calling account, which is 0x5bc4, and this is our calling account 0x5bc4. So only this account should be able to change the owner address of this smart contract. So let's say if we want to change the owner to the second account, and if we try to do that with the second account, you see that we get an error because the modifier was invoked, and we get an error that the account sending the transaction is not the owner of the smart contract. But if we try to execute the same transaction from our first account, which is in fact the owner of the smart contract, you see that the function call was executed successfully and the owner was changed to 0xab2, and that is the second account we have here. Okay, in the next example, we are preventing a reentrancy attack. So the function shouldn't be able to call itself while it's executing its own logic. So let's try this out. We have the value of x as 10, and if we call this with 3, so ideally it should decrease the value of x by 3, that is 7, and I is still more than 1, so it should call the function again with value of I minus 1, that is a value of 2, and it should go on until 3 iterations, that is I is equal to 3, I is equal to 2, and I is equal to 1. So ideally that should happen, but our modifier here should prevent any recursions from happening. So let's see what the value of x is after calling this function. So we have the value of x as so we see that an error was thrown, an error was provided by the contract no reentrancy. So we see that the modifier worked indeed, and let's see if we remove this modifier and then deploy the contract again. What happens? We have the value of x 10, and what happens if we pass in 3 here? So the transaction was executed successfully and the value of x was reduced to 4, which means recursion happened, and the value of 10 was reduced by 3 first, then 2, then 1. So overall 10 minus 6, that is 4, and that's how we know that recursion happened. So that was modifiers for you guys, and I'll see you in the next video.